I think the timer's going. Yes, the timer is going. That's good. So good morning. So what we're covering for today, tomorrow, and Friday is going to be a topic called isometric sketching. And as you know, we were doing precision and accuracy, and the activity I wanted to do, we couldn't do because of the holiday. And so we're going to fill in the gap with moving ahead, covering isometric sketching, and then we'll back up and we'll do the precision accuracy activity. We'll do a final project on the stuff from the first part of Unit 1, and this fits in really anywhere, so it's a good thing. So we're going to talk about what isometric sketching is. First of all, let's talk a little bit about spatial visualization. This is something that is not a particular strong point for me, but it is for some of you. It's just one of those things that, we all have our strengths and our weaknesses. So this is from the PLTW website. To communicate important details and technical information about your ideas and designs, you need to be able to visualize those ideas and represent them in a way that others can understand. I tell my math students all the time, it doesn't matter how brilliant you are and how wonderful your ideas are. If you can't represent those ideas and convey them in a way that other people are going to understand your ideas, your brilliant thoughts just stay inside your head. To imagine 3 dimensions, you need to build spatial visualization skills. The ability to visualize in 3 dimensions is important to many careers, particularly careers in STEM disciplines. That's your science, technology, engineering, and mathematics. Research shows that practicing and improving spatial visualization skills improve success in college engineering programs. And I'll say this, just working at it, wherever you are, whether this is something you're strong at or something you're weak at, by practicing it, you will get better at it. And for those of you that are in geometry this year or will be taking geometry, it will help you in geometry. So what we're going to do in the next couple of lessons will make it easier for you to see things in some of your other classes. So the skills really do transfer over. Let's talk about the isometric view. So there's all different kinds of sketching we can do. We can do like 1-point perspective, 2-point perspective, 3-point perspective. So help me, like I can't do those for my life. We've got like our general concept sketches that we've already talked about. We're going to focus on what's called an isometric sketch. And this is actually so important that when we get to our CAD drawings, our computer aided design drawings, the computer will actually do our isometrics for us. It's a very important view. Engineers and designers often sketch an isometric view to communicate information about objects because an isometric sketch appears 3-dimensional. An isometric sketch is a type of technical drawing, therefore it should include all important information about the object. And what I did on the right there was I expanded the definition of isometric view. It's a form of pictorial representation or graphical model in which all dimensions are parallel to the 3 principal spatial axes are shown in their true proportions. I don't think I read that right, but thankfully you have it in front of you. So we've got over there on the left in a sample of an isometric sketch. When they're talking about the 3 principal spatial axes, it's kind of some technical mumbo jumbo there. What they mean is the X, Y, and Z axis. So if you want to like look down at my hands here, I'll just pull. I'm sitting at my desk at home. Most of you are familiar at this point with your X and Y axis. Okay, so you have your X and your Y axis. And most of the sketching that you do in your algebra classes is 2-dimensional. So you graph a line, you graph a parabola, like what you've graphed depends on how far in math you've gone. The Z axis is the 3-dimensional one. It's the one that pops out. So if I like hold it like this, like now you can see I have my X, my Y, and then my pencil here is the Z. And so you've got your 3 principal spatial axes. That's what they're talking about. And then they're talking about the dimensions of your sketch will show the actual object in its true proportions. And we'll talk about that in the next lesson. Isometric sketch characteristics. The sketch appears three-dimensional because three sides are shown. And you'll see the example over there has the top, the front, and the right, and that is what we're going to stick to in this class, even though you will occasionally see isometric sketched from a different view. All principal dimensions, width, depth, and height, are represented in true proportions. That means that they are all the same ratio as compared with the actual object that you are sketching. Width and depth lines are drawn at 30 degrees from the horizontal. If you glance over to the left at that sketch there, you'll see the width and the depth, and then you'll see a horizontal line, and that is a 30-degree angle there. All height lines are vertical. Note that, maybe even take a moment and write that down in your notebook, that all height lines are vertical. That means they are by default easier to get onto your page because we all know what vertical looks like. And so they're a good place to start your isometric sketch, is to start with that vertical line there to represent your height. And then the shapes of the object faces are distorted. They are not represented as true shapes. Isometric views are very, very useful, but they do contribute a distortion. You can see that in that sketch over there on the left. I think this will let me write on it. If you look up here, like that top corner of the box doesn't look quite right. If that box, if we're looking at it the way we think we're looking at it, that should be further away from us. And so it seems like that angle isn't, it's just not quite right. It might be hard to describe. It's hard for me to describe exactly what's wrong with it. But it is a little bit distorted, and it's a distortion we can live with. In fact, we actually prefer isometrics to a lot of other types of sketches that we can do. So we can live with that distortion, but we do want to be aware that there is a distortion there. All right. Isometric graph paper, at least on the laptop that I'm recording this on, I can't see the graph on it, but I think that is just the glare off of my computer, so hopefully you're able to see it. Isometric graph paper, this makes doing isometric sketches so much easier. When you think of graph paper, you're probably thinking of what we call quad ruled graph paper, where you have the little squares in it, and that is very, very useful for what you want to do in your math classes. If you're trying to do isometric sketches, isometric graph paper is super useful. It is available to download on the PLTW website. I do have some of it in my classroom. If you go to the general channel of our team, I uploaded this particular file that you're staring at. It's on the general channel. You can download that onto your own computer. And if you have a printer, then you can actually print some isometric graph paper from home. As of the recording of this video, about 2 or 3 of you responded to my remind message saying that you were able to print from home, and one of you said that you were able to print from work and had already printed this attachment, so yay. If you're able to do that, please check that out before we get to the later activities in this lesson, because it will make your life so much easier. On the isometric graph paper, those are all equilateral triangles you're looking at, and if you know from geometry, an equilateral triangle, the angles in the I can't even do triangles. That's close enough. So the angles in a triangle are all 60 degrees, and that, and if you take like a 60-degree angle and you slice it in half, that gives you your 30-degree angles. And so the isometric graph paper gives you those angles that you're looking for to get the figure drawn correctly. You don't have to estimate what those angles are. Makes life so much easier. Okay, so choosing the front view. Recall from our lessons on concept sketching that it is important to choose the best possible view for the front of your object. An isometric view is described by the sides that are shown in the view. For example, figure 1, which is the figure on the left, shows a top, front, right side isometric view. The same object represented in figure 2, which is on the right, is a top left front view orientation. Notice what I underlined there. We will use top, front, right view in this course. So when you're drawing isometric sketches for me, you're going to be drawing what you see circled over there on the left-hand side. You're going to draw the top, the front, and the right. Even though PLTW will occasionally show you isometrics from a different view, yours is going to be top, front, and right. And when we get to orthographic projections, and our CAD Fusion 360 is going to do orthographic projections for us, it's going to give us the top, the front, and the right. So we want to get really used to drawing them from that particular angle. It says there that the way you orient an object in isometric view will dictate how you label and show the orthographic projections for side views of the object in later activities. We will get to orthographic projections, but I underlined that in blue. If you want to log into your PLTW account, when you click on those, it'll give you the definition. There's like a little bubble there. You can click on it and the definition will come up. But I do want to talk just real briefly about ortho, the prefix ortho. You can probably think of some words that use the prefix ortho. Many of you have gone to an orthodontist, or if you're into like religion, you might talk about like belonging to the Orthodox Church. And I know there's several other examples that students will come up with. Ortho is, in a way, it means like right or perpendicular. So if you think of your teeth, like you don't want your teeth coming in at all wonky angles. You want your teeth to be perpendicular to your gums, and the orthodontist straightens them out. So think of ortho as meaning like perpendicular, I guess. So when you're talking about an orthographic projection, it means you're looking at it straight on, like perpendicular to the front or perpendicular to the top. What would you see if you looked at it from that angle? Because I like talking about words and how words are put together. All right, guidelines for selecting a front view. We have covered this before, so I'm going to go through this very quickly. A front view typically shows the longest dimension, shows the best shape and characteristic contours, hides the fewest hidden edges and features. You don't choose a front view so that it hides really important things about the shape of the object. Like you want to be able to see as many features as possible. You're probably not going to see all of the features, but you want to hide as few things as possible, and displays the most stable and natural position for it. Now, to be honest, sometimes these things will conflict. So sometimes the most stable position might actually hide more edges, or you might miss like a key contour, or it might not be the side with the longest dimension. When that happens, you choose the best view you can, considering all of these things put together, and you should be able to justify or explain why you chose the view that you chose for your front view. All right, so we have a figure here. In figure 3, the side labeled front is the best choice for the front side because the object is represented in the most natural position. The chosen front The chosen front side shows the best shape description. If you look at that from the front, you're really seeing a lot of the different contours here. You're seeing this shape here. You're seeing like this stuff going on in there. You're seeing all that detail if you choose to look at it from that side. Now, you could pick the right side. That would be a good side for the front because it would show all that detail, but it doesn't show the longest dimension, which we see up there. And so when you're picking your front side, 2 of those sides are both pretty good candidates for the front, so you go with the one that has the longest dimension. All right, sometimes this is where it gets really tricky, and I'm glad that they address this. Sometimes identifying the best front view is not intuitive. For example, most people think of the front of a vehicle as the part that's forward of the passenger compartment. If somebody talked about, like, if somebody came to you and said that they dinged up the front of their car, all of us are picturing like where the headlights are. That's what we think of as being the front. That's the word we would use. But based on the guidelines for selecting a front view, the view shown in figure 4 is the best front view. Now, in everyday language, we would talk about that as being the side of the car. But when it comes to creating a sketch, that the side that you're seeing there would be the front view. And now what they do in the lesson for this, for PLTW, is they go in and they look at the other possible views there and tell you why those views are the wrong choice for the front. So if we look at the top one, it says it's incorrect because this isometric orientation corresponds to a front view in which the vehicle is facing the opposite direction. The front view would, it's backwards from how the original sketch was given to us and the way the object was oriented. Second one is incorrect because in this orientation, the front view is the view looking at the car from forward of the passenger compartment. So it's going to hide the longest dimension. And the last one there is correct. This isometric orientation corresponds to the best front view selected above because it corresponds most closely to the original sketch that we were given and shows like that longest dimension and the most important details. Note, as mentioned earlier, choosing the best front view is not always easy. If two sides of the object seem to be equally representative of the object and meet the selection guidelines, choose the front view that will result in the most natural and descriptive isometric view. It is possible that you and somebody else might disagree on that, and that's okay. That's why it's important for you to be able to justify your choice for the front view. Okay, so what we're going to do right now is we're going to practice with this to choose the best front view. So we have an object there, and we have a bunch of different candidates for the best front view. They are all labeled with a letter, and so I would like you to take, I don't know, we'll take at least 2 or 3 minutes. It gets a little awkward sometimes to pause the video, but I will pause this video and cast your vote on the form provided in the link that I will post. So let's do this. I'm going to go over to the next slide to cover what we're going to do next, and then I'll come back to it so that I can pause it and sit here for a moment and you guys can have it on your screen. So what are we going to do after next? What's next? After you vote, we will look at the class results. I will keep them anonymous, so don't worry about me calling you. I'm not the teacher that does that. I'm not about calling you out and being like, how could you ask? How could you answer that? Like, that's silly. No, I will keep them anonymous, and then we'll discuss what the best front view actually is. So what I want you to do is when you're ready to vote, go over and I'll post the link to the form in the chat for this live session. Lord willing, that will work. And then you can click on that and submit your vote. It's the same way you log in for attendance every day. Then we will work through sketch number 1 in the PLTW curriculum. I will show you, I'll do it on the screen, I'll show you how to get into that so you can see how to access the curriculum and that lesson on your own. I think most of you have a functioning PLTW login. I do have a couple people I still need to roster, and one person who said that they weren't able to get in, so we need to troubleshoot that. If you were able to print that isometric graph paper, then please use it for this activity. It will help you immensely. If you were not able, and I don't have a printer at home myself, so there's like no judgment there. If you just can't print the isometric graph paper from home, do your best to freehand the sketch in your notebook. We're going to work through it step by step from the PLTW website. I will distribute isometric graph paper when I see you on Thursday for the baseline, but until then, just do the best that you can do freehanding it on a piece of regular notebook paper. So we'll end this video, and then I'll go back to that slide. I'll show you what that slide is, and then you can vote from there.